Hey guys, welcome back to my channel Simply Nimi. So today let's do reactions of protein, that is general reactions of protein. Proteins are made up of amino acids and these are linked by peptide bonds based on this polypeptide structure, and then because of different amino acids, right? They react with various reagent and they give colored products, and these are known as colored reactions. And then which and all we can use are albumin, which is found in plasma milk and egg, casein, which is in milk. This is a phosphoprotein which has phosphate groups, and then it does not have cysteine. It has methionine, which is linked by thioether linkage. Casein is conjugated protein. Gelatin is formed from collagen, the connective tissue protein, by boiling with water. Gelatin is deficient in tryptophan, cysteine, and cysteine. Peptones are the partial degradation products of proteins. They are relatively low molecular weight compounds. Gelatin and peptones are derived proteins. Physical properties: albumin, translucent, white, egg smell, neutral. Gelatin, clear, colorless, odorless, neutral. Casein, turbid, yellowish, milky smell, alkaline. Peptone, clear, yellowish, fishy smell, neutral. In this, mostly we have to know about albumin and casein, the appearance, color, odor, and reaction to litmus, which is again TWEN, that is translucent, white, egg smell, neutral. Casein, TYMA, turbid, yellowish, milky smell, alkaline. Now let's see the chemical properties. First test you'll do is heat coagulation test. You'll take 2/3 of the test tube with protein solution, heat the upper half of the tube, and then lower half is the control. If a coagulum is formed in the upper half, you will say that the protein is heat coagulable. That will be albumin mostly. So then you'll add 2 to 3 drops of 1% acetic acid. Coagulum remains. Principle of this test: some proteins when heated get denatured, forming a thick coagulum. If this precipitate is due to phosphate, it dissolves after the addition of acetic acid. Albumin is easily coagulated by heat. Globulin is lightly coagulated by heat. This test is used in the clinical laboratory to detect the presence of protein in urine, in case of proteinuria and all. Then isoelectric precipitation test. If in case of casein you will be doing this, you will take 3 ml of the protein solution, add 1 to 2 drops of bromocresol green indicator, 1% acetic acid, drop by drop until green color is obtained. Then curdy precipitate appears when green color is seen. So you will write isoelectric point of casein is 4.6. What is the principle of this test? What is isoelectric pH basically? This is a viva question. It is a pH at which the protein carries equal number of positive and negative charges, or the net charge is 0. At this pH, protein have minimum solubility and maximum precipitation. Many proteins are easily precipitated from the solution by adjusting the pH close to their isoelectric points by addition of acid, alkali. In casein, it forms a flocculent precipitate if at the isoelectric pH. What is it? It is 4.6. And then this redissolves when high acidity or alkaline solutions are added. So how milk is curdled? Milk is curdled. The casein forms a white curd because lactic acid produced by the fermentation process, it lowers this pH to the isoelectric point of casein, and then casein is precipitated from milk and the supernatant is called whey. Precipitation by salts. Half saturation with ammonium sulfate. So you will take 2 ml of protein solution, 2 ml of saturated solution of ammonium sulfate, and mix well, and you will leave it for some time. White precipitate is formed in case of casein and gelatin. It is precipitated at half saturation. But albumin, this will be negative. This test will be negative. For albumin, you will have to do full saturation test. In full saturation test, you will take 2 ml of protein and saturate the solution with ammonium sulfate crystal. Here you will use crystals. There you will use you'll use a constant saturated solution. So here crystals you'll be adding. There should be some undissolved crystals at the bottom of the container in the test tube. So it should be a lot of ammonium sulfate crystals. So white precipitate is formed, albumin precipitates on full saturation. There's no white precipitate. Peptones does not precipitate on full saturation. If there is, if you add if the solution is peptone with the filtrate, if you do Biuret test using 40% NaOH instead of 5% NaOH, you will get violet color. Peptone is not precipitated even on full saturation and remains in the filtrate. Principle of the test: precipitation by salts. The stability of protein in solution will depend mainly on the charge and hydration. Polar groups of the protein, which are NH2, COH, OH groups, tend to attract water molecules around them, and this makes a shell of hydration. Any factor which removes this water of hydration or neutralizes the charge will cause precipitation of protein. What is salting out? This can be a viva question. When a neutral salt such as ammonium sulfate or sodium sulfate is added to protein solution, the shell of hydration is removed and the protein is precipitated. This is called salting out. This phenomenon is explained on the basis of dehydration of protein molecules by salts. Salt competes with protein for the water molecules, and water molecules available for the protein is less. This causes increased protein-protein interaction, resulting in molecular aggregation and precipitation. Amount of salt required for protein precipitation depends on the size, molecular weight of the protein molecule. Higher is the protein molecular weight, lower is the salt required for precipitation. This is why in serum globulins are precipitated by half saturation with the ammonium sulfate, while albumin is precipitated by full saturation. Why is this? Because higher is the protein molecular weight, lower is the salt required. Salting out procedure is conveniently used for separating serum albumins from globulins. Casein and gelatin precipitated half saturation. Peptone, its very low molecular weight protein, is not precipitated even on full saturation. As the molecules of the protein become smaller, they require greater concentration of salt for precipitation, till finally the stage of peptone is reached. Color reactions by red test. This is the first test which you will be doing. So 2 ml of 5% NaOH in a test tube, 2 drops of 1% copper sulfate. You will make 2 parts of it. First part you will add 2 ml of given protein solution. Second part you will add 2 ml of water and you will leave it. So in the first part, if violet color is found, indicates the presence of protein. This second part, why would you do it? There is no color change also. It is just to serve as control. What is the principle of the test? Cupric ion in alkaline medium forms a violet color complex with peptide bond, nitrogens of peptides and proteins. The minimum requirement for a positive test is the presence of 2 peptide bonds in the molecule. Color varies depending on the number of peptide linkage. Albumin globulin give violet and peptone's dark pink color, indicating that albumin's globule have largest number of peptides linkage and peptones have the least. Avoid excess addition of copper sulfate. So next we'll do xanthoprotic test. 3 ml of protein solution and add 1 ml of concentrated nitric acid, mix it, heat to boil and cool under tap water. Then you will make the solution alkaline by adding 40% NaOH. So white precipitate is formed and this becomes yellow precipitate when you heat it, and then color changes to orange when you make it alkaline. So this indicates the presence of aromatic amino acid tyrosine and tryptophan. What's the principle of the test? Benzene ring system in tyrosine and tryptophan undergo nitration on treatment with strong nitric acid at elevated temperatures. Nitration of phenylalanine under these conditions normally does not take place. All proteins will answer this test because of the presence of tyrosine or tryptophan. The nitrated derivatives are yellow in color. When made alkaline, the shade of the color changes to orange. Modified Millions test. Take 1 ml of protein solution in a test tube. To this add 0.5 ml of modified Millions reagent. Mix well. Boil gently and cool. To this add sodium nitrate drop by drop. Yellow precipitate is formed, then it turns red. So this indicates the presence of hydroxyphenyl group containing amino acid tyrosine. What is the principle of this test? This test is answered by compounds containing hydroxyphenyl group. Tyrosine and proteins containing tyrosine will give a red color precipitate. The reaction involves mercuration and nitration of tyrosine. Mercuric ions precipitate and form a complex with protein. This complex reacts with nitrate ions to give red color. Heat coagulable proteins give red precipitate, whereas smaller molecules of protein like peptones give a red colored solution without precipitate. What is the composition of Millions reagent? That is 10% mercuric sulfate and 10% sulfuric acid. Hopkins Gold test. Take 2 ml of protein solution in a test tube. To this add 1 drop of 40% formalin, 1 drop of modified Millions reagent, mix well. Add 2 ml of concentrated sulfuric acid along the sides of the test tube slowly and carefully. Do not mix. So purple color ring is formed, indicates the presence of indole group containing amino acid tryptophan. Principle of this test: several aldehydes react with the oxidized product of the indole nucleus of tryptophan to give violet color complex. Sulfuric acid with mercuric sulfate is used as an oxidizing agent in this reaction. Coming to sulfur test, albumin is positive, casein is negative. 2 ml of protein solution is taken in the test tube. 2 ml of 40% NaOH is added. You boil it and then cool, add 1 ml of lead acetate. So brown or black precipitate is formed, indicates the presence of sulfur containing amino acid cysteine and cysteine. So the principle of this test: when cysteine or cysteine or proteins containing these amino acids are boiled with strong alkali, organic sulfur is converted to sulfide. Addition of lead acetate to this solution causes the precipitation of insoluble lead sulfide, which is black in color. Methionine does not answer this test because the sulfur in methionine is in the thioether linkage, which is difficult to break with alkali. This is in case of casein. Excess of lead acetate solution, which will form white precipitate. Avoid this. Sulfur is present in protein as cysteine, cysteine or methionine. Majority of protein contain more methionine than cysteine or cysteine. Exemptions are keratins, insulin, certain serum albumins which contain all or almost all the sulfur in the form of cysteine and cysteine. Silk fibroin and many protamines are devoid of sulfur. Albumin answers this test, but casein, which is having methionine, will not, as I said. So Sakaguchi test. 3 ml of protein solution is taken in a test tube. To this 1 ml of 5% NaOH, 2 drops of Molish reagent, 1 drop of sodium hypobromide is added and mixed well. Bright red color is formed. This indicates the presence of arginine. Principle of this test is: reaction is shown by compounds containing guanidine group arginine. Free arginine or arginyl residue is protein react with alpha naphthol and alkaline hypobromide to give a bright red color complex. Coming to the last test, that is Newman's test. 5 ml of protein solution in a test tube, add glacial acetic acid drop by drop till maximum precipitate is obtained. Filter it with the help of funnel and a filter paper. Take the precipitate in a different test tube, add 2 ml of 10% NaOH, boil vigorously, cool it. To this add 1 ml of ammonium molybdate and 1 ml of concentrate nitric acid. Canary yellow color precipitate is formed. Casein is a phosphoprotein. Principle of the test: the organic phosphate present in phosphoproteins is converted to inorganic phosphate on boiling with strong NaOH solution. Inorganic phosphate reacts with ammonium molybdate to form ammonium phosphomolybdate, which is canary yellow in color. Casein, being a phosphoprotein, answers this test. Thank you. Bye.